Welcome to another exciting Java class. In this class, what I would like to do is I would like to review for the final, which is due next week. We're not going to have to come to class to submit the final. In fact, I would wholeheartedly encourage you to do the entire thing online well in advance of class, just in case you have some submission issues. Instead, what I'd like to do is announce this is our last Java class for the entire year. No more Java. And what we can do is we effectively can open the floor for questions. But before I do that, I thought I would go through the final and give you a basic introduction to the idea behind the final, answer some basic questions like, what is it and why are we doing it? And how does this thing matter? And then after we do that kind of review, I think we should feel at liberty to ask as many questions as we like. And if after that there are no questions, you guys are done and you can go. So that's the lecture. That's my plan. So my goal in this lecture is to make sure that everybody understands the final, that there are no outstanding questions. And my first question for you, did anybody have any trouble with the homework? No? No questions for the homework? All right, then, without further ado, what I will do is dig straight into the final. So I uploaded the final last week and gave you all a deadline. And what I'd like to do, and I think it might be productive, is just sort of review certain things that I've done since it was uploaded. And one of those things which I've done is I've given you your example jar file. So this is the jar file which will drive your program. It will serve as the input to your program. So you will read this jar file in an attempt to address the specification on the final. Some people have said to me, well, Professor, what if I don't want to use your code? What if I want to write my own code? That's fine. I'm not offended. It's perfectly valid. In fact, I even prefer it. Write your own code. That's just, I write my code, I do what I want. You write your code, you do what you want. As long as it works and meets the specification, I got no problem with that. So then it says, given a jar file, and here's the jar file for which you were given, uploaded, with the classes required in order to run a program. Well, now, how do you know this program runs? Well, here's the jar file, futils.futil.jar, which I've uploaded. I can download the jar file, and I can run it on my computer. I type java -jar, and then I put in the jar file, and it runs as a standalone program. And here's what it does. It prompts me for a file. I click on a file. It prints the file. That's it. It's done. That's what it does. It's not a particularly remarkable program. When I look at the directory, is there a question already? When I look at the directory, sure there's no question back there? I hear the murmuring. It says it's 3.8 megabytes on disk. That's an awful lot for such a little program that does so little. But what it contains is all the class files that are needed to compile the class file called futil.java. So when you look at futil.java, you can find there are many dependencies. It's in futil.java. Everything sort of depends on it. It depends on a lot of other things. So in order to compile it, what I have done is I've created what's called an optimized jar file. That is a jar file which is minimal relative to the program. So in other words, I don't need every single class in order to make futil.java run. I'll give you another example. here is a program called Book Examples. It says Hello World. If I go to Hello World, I don't see it. To double click. Yeah, if I go to Hello World and I run the Hello World program, we can see it is quite elegant and small relative to the enormous code which contains it. That is, I have a big project with perhaps 4,000 or 5,000 Java files. But to make this work, I only really need one file. So in order to optimize for the size, what I have is a program which will allow me to pack classes into a single jar file. And so what you can do with this program, should you elect to do so, is you can navigate into the bytecodes of the output for the compiler. So what I do is I go into my lion J for P directory and I look for the output of the compiler, which is in a folder called out. And I happen to know that my Hello World code is contained in Book Examples Chapter 1 Hello World. And we can see the bytecodes are residing inside of a file with the .class suffix. That's what compilers do. They take source code and they make bytecodes, and they start with files that end with .java, and they transform them into files that end with .class. So I use bytecode engineering to read in the .class file. And this gives me a fully qualified class name. And now for my output, I will output a jar file which will be a standalone space minimal jar file containing only those classes needed in order to run Hello World. In other words, it doesn't have to be this huge humongous thing for distribution. For the purpose of distribution, we can make a very small jar file which just runs. So now if I say OK, it shows you that in 1 second it was able to create a jar file which excluded all of these extraneous packages and included only the one thing, Hello World, that was accepted. Then it packed it into a hello world.jar file so that when I go and I say dir star.jar, I see there is book examples and it takes only 800 bytes. And in theory, it should run. So I should be able to say java -jar book examples, and it runs. So in other words, what it's done is called static dependency analysis. It said, here is the bytecodes for the class. Here are all the other things it depends on. It didn't depend on much else. We'll only include that which is needed in order to make it run. This optimizes the loader's speed because that means you don't have to load a whole lot of stuff when you read in the jar file. It also optimizes the download speed if you're going to deploy the jar file on the web. Now I can run the program in only 800 bytes, whereas the other program, Feudals, needed 3.8 megabytes. That's an awful big difference, right? I mean, it's like it's 1,000 times difference, 3 orders of magnitude difference, big difference. So I'm thinking to myself, well, this is great. Now I've got a way in which to generate the optimized bytecodes. But what if I just wanted to pare down the source code in the same way I pare down the bytecodes? Well, if I want to do that, then my input will be optimized bytecodes in a jar file, and now my output must be optimized source codes, also in a jar file. So if what I did was I just read hello world.jar and said the only thing you need is the hello world class, I could say to the class who is interested in running it, the only thing you have to compile is this one file, bang, you're done. You don't need all of these other things. So your job for the final is to identify only those source code files which correspond to the bytecodes inside of the given jar. So if I give you feudals.feudal.jar, you'll read in all those classes, find the corresponding source code, and then generate a jar containing only the source code which corresponds to those bytecodes. That is, it's giving you what I would call a static dependency analysis on the source code, giving you only that source code which you need in order to make your code run. So now we have the basic idea. Let's go back and read what it says. So given a jar file with the classes required to run, that is I'll say a bytecode minimal static dependency analysis bytecode set, right, of classes to run, and a folder with more than enough Java source code. That is, you have sufficient number of lines, but I don't need all of them. I just need the sufficient number, the necessary and sufficient number of source code files. To run the program, create a new output folder that contains only the source code file that corresponds to the bytecodes in the jar file. So you're already given the optimized jar file. Now you can find the source code correspondence with the contents of the jar file. What does that mean to you, the programmer? It means you have to open the jar file. You have to go through the jar file. You have to read all of the class file names in the jar file, find the corresponding source code file names in the source folder, create a new jar file with only those source code files. So you've got to do a kind of a copy based on a read from a packed jar file. That's what you have to do. So thus, if the jar file contains the blob feudals.feudal.class, the output file will contain feudals feudals/feudal.java. In other words, the .java file corresponds to the .class file. And you'll have to go through every single one of those things. So then your question is, okay, what exactly is inside of the jar file that you're giving me? Right? How can I find out? Well, the homework you did that was due today, right? What it did was it went through, unpacked each one of the blobs in the jar file input, and then proceeded to do a string fragment pattern match. So it can actually find classes in that jar file. So you did a substantial fraction of the final for your homework, which was due today. So that was done already. I was supposed to give you a head start. So if the jar file does not contain the blob, then the output file will not contain the Java code. Right? So the necessary and sufficient condition is if it's in the jar file, it's in the output. If it's not in the jar file, it's not in the output. So you can do it a couple of different ways. You can get a set of all files for source code in the source folder and look up each one in the jar file, or you can use the jar file to figure out where the source code files are. Go either way. Thus, you will have to compare files in the source file with the blob names in the jar file. Submit the source code and show the output of your code with a snapshot of the screen displaying the file system containing the output folder. Please bring your questions to class. Did anybody bring any questions to class? No? Great, you're done. Class dismissed. Oh, you're not leaving. I see that.
What are blob?
Oh, a blob.
Yeah.
So inside of the jar file, there are many binary blobs which represent other files. And you can extract those. How would you do that? How would you extract the jar files using the JDK command line tools? Unzip would do it, but if you are using the JDK command line tools, you don't get unzip. Unzipper is not a JDK command line command. JDK command line command, Java, Javac, RMIC, right? In other words, if you go to program files, You see these exe files? These exe files are in the JDK bin, right? Every one of those exe files is a JDK command. What that means to me, the user, is that if this binary directory is in my path, I can type any of these names. So for example, Java is a JDK command. Javac is a JDK command. JavaDoc is a JDK command. Java WS, JDK command. All commands. So which of these JDK commands is going to allow me to extract a jar file? I'm just going to sit here and make faces at you. Soon I'll start drooling. So can anyone give me a guess? How do I extract? You're not who? Javac is going to be the compiler. But my question is, what command will I use to extract jar files? Yeah, the jar command. Yes, thank you. Thank you. So, in theory, if we find some jar files, here's one called book examples, we can make some directory, which already exists. Oh, really? Why can't I move this? Oh, MV is not recognized. I'm in Unix. Sorry. Unix is in my brain. There. I moved a file. Good job. So now what I'm going to do is I'm going to use the jar command to extract -x verbose v the file f xvf extract verbose file book examples. Now we can see what is contained in the jar file. A manifest is contained in the meta-inf directory, and a single bytecode element is contained in book examples chapter 1 blah blah blah. So if I typed Java book examples chapter, oh, it's backslash, isn't it? Chapter, whoops, backslash hello world. It's having a problem because I need not backslash but dot. There we go. Try that again. There it is. So I have typed in Java using the fully qualified class name, and then it used the present directory to find the class because the present directory is in the class path. Had I changed directories and did it again, it couldn't load it because it's not at the correct attach point. If I were to go into the correct attach point and use only the jar file, Java -jar, book examples, where is this thing? Star.jar? Where is this thing? Jar. Java -jar, book examples. It runs. How does it know the name of the class? Well, I see that in the book examples directory, there's nothing in here to tell me where the main is. But wait, there's a meta-inf directory. What do you think could be in there? Well, let's have a look. So I go to the meta-inf directory, and it says it has a manifest. So let's look at the manifest in the meta-inf directory. And sure enough, it tells me where the main class is. It says the main class is, and it gives me a fully qualified class name. So apparently, when you run the packer for doing static dependency analysis, it not only makes a jar with all the classes you need to run the program, it also makes a manifest which tells you where the main class is. Because as you know, a project can have more than one main class. It can have many mains. In fact, mine does. Tons of mains, lots of mains. So knowing which main to run is critical, and the only way you can know is by creating a manifest which goes in as part of the jar, which allows you to run the main. That's what's in the jar file. That's how you unpack the jar file using the JDK commands. But you already know that you can do it with your own program because you wrote such a program for homework. And that program was called, what was that program called? I can't remember. Can anyone remember the homework that was due? Yeah, the jar utils, right? Jar utils, the example from last week. So if you were to run jar utils, and you could certainly do that, right? Here's the jar utils. Instead of finding this file, jar annotations, or whatever the heck it was called, we could comment this out and get the read file. Now we can navigate through the file system, find the Hello World program, and then decode it using jar utils. So presumably that's in the foo directory, or whatever we called it, and there it is. Right? Now if I read it, he says, look for a fragment. So he's inputting this. I did the homework, right? So let's input it. Let's look for hello. That's what we're looking for, right? And it says, aha, I found hello. Hello world.class. So as he went through hello world.jar, he was able to find a series of blobs with names. Each name corresponded to a series of bytecodes. And he looked at the name, and he compared it with my string fragment, hello, and he said, aha, hello world contains the string fragment hello, matched it, and printed it out. Let's do it again, only this time we're not going to do hello. This time we'll do it again, only we'll say something else, not hello. Let's search this jar file for the term wow. And certainly, he couldn't find the Hello World class with wow in it, because there is no wow, only a hello. What do you think of that? Good, right? So now the next question is, what would you do given all of these, given this wealth of frameworks and all these things that you know now about Java? How would you approach the problem of finishing this final? I'm going to start drooling again. You have to tell me. You can't just sit like lumps on bumps. You've been doing that for too long. You must participate. I'm pouting now. Before I was drooling, now I'm pouting. You have to help dear Professor Lyon before he starts talking about himself in the third person. I'm going to go up here, I'm going to be stuck. They're going to come with the straitjacket, and I'll end up in the rubber room. And that'll be it for me. And then they'll give you somebody else who's probably even less coherent. Did you know that in this country, if you don't participate in the class, they publicly cane you? It's true. They take you out over here and they throw the rotten tomatoes, and then there's a caning. You haven't seen that yet, have you? That's because up until now, everyone has participated, except for you guys. All right, well, it's not true. There is no caning here in public. Not in public. We do it in private. So the class sounds lost. Who's lost? Okay, who knows what to do? Okay, so you're neither lost and you don't know what to do. Right? Create the jar file. Okay, great. How can you list all of the source code in a directory? You've already found out that there's a thing called a jar file which lists all the blobs. And you know you have to compare the blob names to a list of file names. Right, right. So where are you going to find the source code? Well, somebody said, we didn't get the source code because you didn't give it to us. And I said, geez, boy, I'm really mean. How come I didn't give you the source code? And you said, I don't know. Okay, there's the source code. It was there since the beginning of the semester, src.zip. So it's there, right? And so then the question becomes, how will we make a big list of all the files in the source code? How can we do that? How can this be possible? You import? Really? I mean, here's the source code. I think I can download it, right? Does it download? Your download will start shortly. So I've got this thing called source.zip. It's downloading, albeit slowly, but I also happen to have the source code already in my folder. So you can get the source code from any one of a couple of places. From the compressed zip file, which is downloading slowly now, or you can get it from the already expanded file system. Right? So suppose you started with the already expanded file system. How would you get a list of all of the files in the src directory? Get files. Is there a get files? Get files. There's a dir list. Now, dir list might be able to help us. And dir list does have a get file. It lets you pick the root directory. It requires a file filter. I wonder if there's a main method in here somewhere. Oh, yes, there is. You get the file list, you print it, and then you print done. That sounds good. I like that. Let's run it and see what happens. Select a root directory. So here's J for P. Here's source. I think that's my root directory. Open. And it looks like he gave me a list of all of the Java files. So that's in there. That is certainly a legitimate way to go. Anything that ends with .java is going to be something that could appear in the output if it also appears in the bytecodes of the jar file. Got it? How else could I have found the list of all of the, we'll call it source code files? How else? I got a zip. I could use my little jar utils to open up the zip file and print those out. That's legitimate, right? So I could do it another way. But I like what I did here. This is fine. So next question becomes, how will I know if the class files that I'm seeing are the same as the source code files that I'm encountering? What will I do to match these files? Any ideas? Well, for every file name that you have, there should be a corresponding bytecode, right, in the jar file. So if that isn't there, then it won't appear in your output. So let's look at this together. Here's what we see inside of the jar files. There's a book examples, and book examples has hello world, and hello world has this bytecode. So now it seems to me in the output we should be able to find something called book examples chapter 1 hello world, right? So if I go out to src, the root directory, go to book examples chapter 1, and sure enough, there's a hello world.java. What that means to me is that there has to be in your output a jar file which contains a blob that is named book examples / chapter 1 hello world / hello world.java. That has to be in the output. What do you think of that? So let's look at this. Where's my? I wanted to find my final. So given a jar file with the classes required to run a program in a folder with more than enough Java source code to run the program, create a new output folder. An output folder that contains only the Java source code that corresponds to the bytecodes in the jar. So the output is a folder, which means you have to copy, right? You don't overwrite. You copy the source code from your source files into the output. Okay, how do you copy a file? Is this what they call a pregnant pause? I'm just sort of looking around. Nobody wants to tell me how to copy a file. We're burning time, folks. Well, how about here it shows you how to copy a directory. What this does is it has a mechanism to copy everything in the directory and output to another directory. I wonder if this can work. This copies a folder with a source folder and a destination folder. Give it a list of files, it'll copy every file in the list. And it does it by creating a file input stream and a file output stream, and it's copying it one byte buffer at a time. One byte buffer at a time. This kind of looks like it might work. You could try it. It's supposed to copy directories. So we can open src, and now we're going to copy it to, let's copy it to foo. Why is it opening the second directory as foo? That's fine. Did it do it already? Seems like it went way too fast. Nope. Here's the input. I don't think it made an output. Oh, it says third directory. Wonder what that is. Oh, wow, look at that. It generated a whole bunch of stuff on output. In fact, it looks like it copied a whole bunch of stuff. Yeah. And it's even got the right time and date stamp. So it just created a whole pile of... I thought it ran too fast, but apparently it's just a very fast program. And it made the copies happen. So that's kind of neat. So you've got a nice example here for copying a file. Actually, a whole directory full of stuff. That's pretty slick, actually. Let's find, here's something called cat. There's dir copy. What else do we got? Feudal might have a copy file. Copy file into directory. Got a few of these things. Looks like this inputs a jar file and a working directory, reads all the jar file bytes, and then copies it into a different place. I'm not sure that's what you want, though. What else do we got? We're really working more with text, but it really won't matter, I think. You can copy text files, or see here it says binary copy file. That might be good if you were just copying binary, but you can treat a text file as though it were binary. So here's the read file, there's the write file. It reads the whole thing into a single array of bytes and then writes it back out again. And then it says copy done. What could possibly go wrong with this? Any ideas? This reads the whole file into memory. What if the file is big? You could run out of memory. Will that ever happen for Java source code? No, because no Java source code program is going to exhaust the memory on a modern laptop. So reading them in all at once might be very efficient. So this will be your buffer. You read it in all at once, reads all the bytes, then you write them all out at once. Binary copy file. That looks like a good one. So let's try it. Paste. Binary copy file. We'll start with source code, which is not binary, but we'll just do a binary copy anyway. It won't matter. So we'll look for the source code here. Address database.java, and we'll save it in foo. And we'll call it wow.java. Copy done. We'll go in. And we should find wow.java, and we do. It's 25K. Emacs wow.java. What do we got? Looks pretty good. Copied the whole thing through. Emacs colorizes it. And normally it doesn't come out with colors, you know. So copy file is a subroutine, or we'll call it a public static method in Feudal, right? Feudal.java has a copy file routine. We can certainly use that, or we can write our own. Let's see now, get read file. You know what will happen here is you'll be getting your files from a directory that contains a whole bunch of other files. So you already know now, using dirlist, how to get a list of all the files. Read bytes, we can look at how that works. So he's making a file input stream, reads the whole thing after he figures out how many bytes he needs, and then closes the file input stream. So he reads it in all at once, and then returns a nice big array of bytes. That represents the contents of the file. Got that? So we got binary copy file, reads all the bytes, and then writes them out all at once. For that, we create a file output stream. We pass in the file name. We pass in the bytes that we want to write. Writes the whole thing out at once. Very efficient. Hello, come on in. So now I know how to read a file. I know how to write a file. I know how to list all the files in a directory. I can get all the blobs from my jars. Now you guys got to piece it together. You got a question? No? No questions yet? We're done. We're finished. We just did the whole thing. I think you guys came in a little late, didn't you? It's like you're 43 minutes late. And we did the review for the final. But lucky for you, I've recorded it. And if it works, maybe I'll be able to upload it and make sure people can see it. So, but you're welcome to come. Come. Yeah, come on in. Oh my God. What, do you guys all come together? So you come in 43 minutes late and you sit all the way in the back of the room. I think I should taunt you. Wait, I am taunting you. I don't know. So you came in a little late. It's okay. You can still ask me questions. You got any questions on the final? No? I feel being late for the final review was not a good strategy. Oh no, don't be sorry for me. I'm sorry for you. It's not like I'm going to punish you or anything. I'll try and upload it. I hope it works. But if it doesn't, you'll have to get the notes for somebody else. And the people who sit in this classroom I've seen do not take notes. So good luck with that. So what else can I tell you guys about the final? We now have all the steps. We know how to list all the files in the directory. We know how to see all of the bytecode names in a jar file. We know how to copy a file. Given an input file, we can create the output file in a separate directory. Remember, don't overwrite your source code, or else you will be unhappy because you won't have it anymore, especially if you make a mistake. Probably you will all make mistakes. What else can I tell you about this final? How can I make it easier for you? You know where to get the source code? Right? Blackboard's got src.zip. It's all in there. What about this idea about the bytecodes in the jar file? Why don't we have a look and see how the example looks, right? I think that might be very educational. Dir star.jar. Here's feudals.feudal.jar, which I uploaded to Blackboard. We'll copy it to this Scratch directory called foo. better yet, maybe we'll just move it, because I don't need it anymore. Well, foo has got so much crap in it, I think I should probably clean it up a little bit. So everything except for feudals.jar. Here, what we'll do is I'll just select everything and move it to the trash. And we can get rid of this stuff too. So now when I go in, I should see only one thing, which is correct. Let's see what feudals.jar has in it, shall we? Jar minus xvf feudals.jar. And it's got a whole bunch of stuff in it. Tons of stuff. Right? Now, what can we see? Wait a minute. These aren't straight bytecodes, are they? Some of them have a $sign. CD GUI, CD run, dir. Look at all these things with $sign. Dir, star, dollar, star, star. What can I do about all of these things with $sign? Will I find Java code that corresponds to the bytecodes with the $sign? Will I find run vec nd pane 1, oh, I'm sorry, here it is, run vec nd panel $3.java. Are you going to find that Java source code in the source directory? Eh? Eh? I do that to bother you. Eh? Does that bother you? Doesn't bother me. Huh? No? Yes? Eh? What did he ask? Huh? The source files will not have any correspondence with run vec nd panel $3. That is not a legitimate class name. That is an output from a nested reference data type. Anything with a $sign in it is the output from a nested reference data type. So when you go to GUI.run, you may find run vec nd panel, but you will not find run vec nd panel $3. That's not a legitimate name for a class that you would write. So let's have a look and see what we can find. GUI run what's it called? ND panel something or other? I don't see it. Run, oh, it's called run vec ND. Run vec. Run. There it is. So here's run vec nd panel. There is a run vec nd panel, but where's the run vec nd panel $3? What does that correspond to? Well, the answer is it's a nested reference data type. Somewhere in here, it says new, right? That run integer spinner slider must be an anonymous reference data type. That will give rise to a run vec nd panel $1, 2, 3, or 4, depending upon which anonymous class it is. This is probably the first one. There's probably another one coming up. And there it is. Whenever it says new, inline like this, that's an anonymous reference data type. It cannot correspond to a Java source file. The murmuring is a little distracting, folks. You want to tell me what the question is? So, as it happens, here's another one. This might be the third one, right? So all of those anonymous reference data types have no correspondence, and you can ignore them. But the other ones you cannot ignore. So it has to be a file name that does not contain a $sign from the jar file. For that, you will find correspondence with the source file. What are the other differences? Well, I can tell you that all of this stuff with the $signs, this is all anonymous reference data types, all generated internally by the Java compiler. But if you said you wanted to list all files that didn't have a $sign in them, remember for homework you said let's find all of the blobs that match a specific string fragment, right? Fragment was input, right? So when we looked at the fragment that was being input, that's what we were searching for, not what we were trying to exclude, you see. So if you looked at your Java, what was it called? Jar utils, right? Jar utils. He says select a file for input. I say, okay, run, fine, run it. Now he's going to prompt me for a string fragment. That's the string fragment I want to look for. It's not the string fragment I wanted to exclude. In other words, if you wanted to do last night's homework over again, identically with what you did last night, except for a difference, the difference would be input the string fragment that you want to exclude, not the one you want to match. So now if you said to me, well, let's try and repeat the experiment from last night. We'll go into the lion directory. We'll look at this jar file that you're giving us, and I think it's called feudals.feudal.jar, and I'm going to search for a class called feudal and try and find it. And sure enough, he finds it, but he also finds other things, right? He finds feudal $2 and feudal $1. Well, that has to correspond to the anonymous reference data types that feudal contains. But the only thing you're going to want in your output is feudal.java. You're not going to want the feudal.$2.java because there is no feudal$2.java. That's not there. So how do I eliminate all of the things that contain a specific string fragment? Well, let's have a look and see what we did. I prompted a fragment, but this is the search fragment. This is the include fragment. Maybe we should have a separate fragment, which will be, I will call it the exclude fragment, right? So I want to include certain things. I also want to exclude certain things. And we'll call this the exclude fragment. And now, instead of passing in just the fragment, we'll pass in the exclude fragment. Whoops. What's his problem? Oh, right, because I didn't modify the subroutine yet. So now here comes the fragment coming in, and now let's put in the exclude fragment. I think it needs a comma. Yeah, that looks about right. So now we'll take the exclude fragment. If it contains the fragment we're interested in it, and we can print it, and if it doesn't s of j dot contains the exclude fragment. So what we're doing now is we're going to match it for things we want, and we'll make sure that it doesn't match for the things we don't want. So now when I go to print, it'll prompt me for something to include, and then it will also prompt me for something to exclude. So now he wants a jar file for input. We'll use this one. The include fragment is futile. The exclude fragment is $. Right? So that will give me only those things, only those classes that contain futile, and exclude the $. That's so important, right? Because we know those $, classes don't actually have a corresponding Java source code, because the nested reference data types are buried in the Java source code. Got it? Well, what do you think? I mean, am I making sense, or am I just sitting here sort of entertaining myself? No? Does it make it easier? So now you understand, right? Let's do it again, only this time what I'm going to do is I'm going to match everything except for oh, I know. Well, let's just look for class. Anything with a class and no $sign has that. So we'll get all the classes and no $sign. We just change the input, right? Because it's a string fragment. I happen to know all the blobs will end with .class. So I'll start with futile.jar. If it has a class in it, .class, I care about it. If it has a $, in it, I don't want it. And now we have a list of all of the classes that are not nested reference data types. Sweet. That is sweet. That's just what I needed. Right? That looks great. I love it. But these don't correspond exactly to the Java source code because there's a difference. The Java source code is going to look just like the class files, except for a small difference. And what's the difference? It ends with .java instead of .class. So how would I substitute .java for .class in a string? You guys are killing me up here. Here's the string of interest right in here. Can I replace? What do you think of that? You think that could work? I don't know. Want to try? Yeah, sure, why not? Yeah, sure, you betcha. I better stop or I'm going to end up doing your final for you. So the include fragment, we know it's going to be .class on the input. It's going to exclude $sign. And now what does it print? The actual name of the files you'll be looking for in your output folder. So these are the files that I would expect to see on your output. How am I doing? I got to stop now, because if I finish your final, I'll have to assign you a different problem. Are there any questions in terms of what I've done so far? Now, last time I tried to cut and paste jar utils, it was a bit of a disaster, a bit of a mess, really. But I have a feeling that you can attach more than just one file. So maybe if I go in and edit, I can attach one more file. I don't know. It's just one of those things. Browse my computer. And so now, J for P, SRC, utils, wasn't it jar.utils or something? There it is. So we'll open that up. That's today's class code, right? And I'm opening it up now and uploading it to your final so that you don't have to deal with the idiotic cut and paste issues that Blackboard has. So now you can see it's an extra attachment. It's not a particularly remarkable thing, but I wanted you to have it. We developed it here in the class, and then I'm going to upload today's lecture in case you need to watch it again if you are late. And then I'm not going to adjourn the class if there's more questions, but I would say that by saying this, you probably won't ask questions because you almost certainly wish to leave. And you know, the more questions you ask, the longer it will take to get out. And therefore, you will not ask any questions. All right, let me put it a different way. Between now and when the final is due, I will not entertain any private questions about the final. This is your very last chance to ask questions, to put everybody on an even keel. Everyone should hear your question, and everybody should hear my answer. This is not like a standard homework. It's the final. So I can't just give one person hints and not give it to everyone. Now is your time to ask questions, and then the hints will be the same for everyone. So then you're on your own between now and the final. And let me caution you, please do not copy one another, because I've gotten some feedback from the grader, and he thinks there may be some copying, and I said we're going to have to be very strict about it. Now, you may or may not know this, but there was a time when I taught a class, and there were half a dozen people who got F for the final because of copying. They got 0, and they were all very upset. So because we're reaching the end of the semester, and because you don't want something like 0 for a final, I would strongly discourage you from copying from one another. It is policy here on campus, okay, that we do not copy without repercussions that are severe. And this can include getting a 0 on the final, which could mean flunking the course, because the final counts big time, right? Like a third. So your homework counted for a third, your midterm counted for a third, your final counts for a third. So I counted homework a lot. So if you're doing homework as you go, I think you did all right. So any more questions? Last chance. Going once? Going twice? There are no more questions in the class. I declare this to be the end of Java in 2014. Wow. How about that? Thank you. Have a good break.